Have you ever wondered how a figure skating spin works? Well, it's because of angular momentum. Angular momentum is what we call in physics when something is moving by rotating. The equation for this is L equals IW, or the angular momentum, represented by L, equals the inertia, or the mass, which is represented by I, times the angular velocity, or speed of rotation, which equals the W. Another principle of angular momentum is that all motion in the system must be conserved. So if we increase the inertia, we must decrease the angular velocity, or vice versa. So when starting a spin, a figure skater does crossovers in a large circle, goes into a smaller circle, and snaps into a position. This snap into the smaller circle is what causes the angular momentum, because you're changing your radius to be smaller, and to compensate, your inertia must go up, so that your angular momentum remains the same. You've also probably seen how they go from one position to another. This works also because of angular momentum. When changing positions, there is a decrease in the moment of inertia. The equation for this position change is the inertia equals the mass times the radius squared. So let's take a camel position to a sit position. The camel position has the skater's leg and a larger radius than in the sit position. So when the radius is less, the inertial moment must be less because you're not changing your mass midway through the spin. Because of the law of angular momentum conservation, the angular velocity increases when the initial moment of inertia decreases. There's also another type of change of position. It's a foot change of position. This is when the free leg of the skater pushes in the direction of rotation, which creates additional force and increases the angular velocity that keeps the skater spinning while they change feet. So that's basically all there is to it, to a figure skating spin. The other thing a figure skater must remember is to keep their mass over their center of gravity so they don't topple over, but that's a topic for another day. Hope you learned something. Thanks for watching.